Hi, we're going to be discussing dispersion and rainbows today. Hopefully, everyone in the audience has either seen a rainbow in person or in a picture. Pretty sure it's a pretty common thing. A rainbow is made up of 6 colors. We've got red, orange, yellow, green, blue, and violet. And sometimes indigo is thrown in there, but for our purposes, we're just going to stick with these 6. Light travels in wavelengths, and so each of these different colors has a different wavelength. When our eye receives pure wavelength light, we tend to see only one of these 6 colors, depending on which wavelength our eye is seeing. The thousands of other colors we see are our eye's response to the various mixtures of wavelengths. Sunlight, for example, is made up of what's called white light. And white light is a mix of all of the visible wavelengths, which is why sunlight is able to help create rainbows. And all of the other colors that we see that aren't of these 6 colors are due to a mixture of wavelengths that our eyes are seeing. And the different colors that we see are how our eyes interpret those different wavelengths. To understand how sunlight and water are able to create a rainbow, we need to understand 3 different words: dispersion, reflection, and refraction. So dispersion is the spreading of white light to its full spectrum of wavelengths. This occurs whenever there is a process that changes the direction of light in a manner that depends on wavelength. The order of the colors of the rainbow are lined up by their wavelengths, with red being the longest and violet being the shortest. Reflection is the change in a light ray's direction at an interface between 2 different media so that the ray returns into the medium it came from. In layman's terms, reflection is when light is traveling, for instance, through the air and runs into a mirror. It will bounce back from the direction that it came, and that's called reflection. Refraction is the changing of a light's ray's direction, often called bending, when it passes through variations of matter. So this is a little different from reflection. Refraction, the light is still going in the same general direction, but it's just bent instead of bouncing back to the direction that it came from. So how does this work with rain and sunlight and rainbows? So the sunlight travels to the water droplet, and once the light goes from the air to the water, it is refracted. And because red light and violet light have different wavelengths, they start to travel in different directions, or at least at a different pace. The light is then reflected off of the back of the water droplet and continues forward until it leaves the water droplet back into the air and is refracted again. So here you can see the red light and the violet light, but in between these are orange, yellow, green, and blue as well. So how does this work with what we see? Because here it kind of just looks like a couple lines of light going through a water droplet. So here we have our cute little person, and the sunlight is behind him and the water droplets are in front of him, and this is generally the scenario of how the lighting should be when you are seeing a rainbow. So light travels in cones, which you can kind of see by the depiction here. They're kind of in a cone shape. And as you can see, some of the light travels above and some of the light travels below where this guy's eyes are. And so because of this, the highest cones, we only see part of the light. So we only see the red light from this up higher cone, and from this lower cone we only see the violet light instead of the red light. And all of the other colors are shown in cones in between this. And so because of this, we see the rainbow in the order that we do, from red down to violet. If you've ever seen a double rainbow, you might be wondering why it's dimmer and why the colors are in the opposite order that a normal rainbow is. So in our normal rainbow setting, we have the sunlight that goes into the raindrop and is reflected once off the back and comes out and hits our person. In the case of a double rainbow, the sunlight hits the water drop at a different angle than the first one. And because of this, it is reflected twice in the raindrop before it re-enters the air. And this causes the light waves to be flipped. Reflection, sometimes the light will, some of the light will keep traveling in this direction and some of it will bounce up this way. And so some of the light is lost for each reflection. And because the double rainbow has 2 reflections instead of 1, a lot more of the light is lost in the second rainbow than in the first one, which is why the second one appears dimmer than the first one and why the colors are flipped. Thank you for watching. That's all we have.